Right, so in the previous video we saw the first two theorems of the circle. The first theorem was that a straight line joining the center to the midpoint of the chord is perpendicular to it. That was the first theorem. And the second theorem is the converse of that thing, that if I draw a perpendicular from the center to the chord, then it will always be bisecting the chord. So these are the first two theorems. Now we move to the third theorem. The third theorem is that equal chords of a circle are equidistant from the center. So if I've got a circle over here, and if this circle, in this circle, if I've got two chords, one chord over here and another chord over here like this, if it is given to me that AB and CD are equal chords, so if it is given to me that AB is equals to CD, then it can be proved to prove that they are equidistant from the center. So from center, if I take a perpendicular distance over here like this, so if this is M and this is N and they are perpendicular distances over here from O, then it can be seen that to prove that OM is equals to ON. So this is what is going to be the to prove part. So to prove is that they are equidistant. Now we always know that the shortest distance between the two a line and a point will be the perpendicular distance between them. That's the reason we are going to take this as a perpendicular part. So we can say as construction. So we are going to say construction में सबसे पहले construction we are going to say draw OM perpendicular to AB, ON perpendicular to BCD, and then join OA and OC. So this is what you need to join OA and OC. So right, you just join this thing. So what we are trying to prove is OA is equals to ON. Now this can be easily done. What are the things we already know is that AB is equals to CD. Now in the previous theorem, we proved that if I drop a perpendicular from O to AB, automatically AM will be equal to MB. So we see that if AM is equal to CD, AB is equal to CD, and M is the midpoint and here N is the midpoint, so automatically AM will be equal to CN, because half AB will be equal to half CD. So AM is equal to CN. So we will be able to see that this is equal to this. These already are equal because they are the radius. So these are the two radius, and these are 90 degrees because it is given by construction. So accordingly, by RHS test, both the triangles are congruent. Hence OM is equal to ON. This is how we are going to prove the theorem number 3. So for this, we are going to say is, first of all, we are going to say is AB is equals to CD given. Therefore, half AB is equals to half CD. Therefore, AM is equals to CN, because perpendicular drawn from center to chord bisects it. Okay, so that's why AM is equals to CN. Now we are going to take the two triangles. So in triangle AMO and triangle CNO, we have AM is equals to CN. That is proved above. The next we have is OA is equals to OC radii. An angle OMA is equals to angle ONC, that is perpendicular given. Therefore, triangle AMO is congruent to triangle CNO by RHS test, and accordingly we have OM is equals to ON. So that's by CPCT. So this is how we are proving the third theorem. The third theorem is that equal chords, AB and CD are equal chords. Equal chords are equidistant from the center. Equidistant from the center, yaani the distance, the perpendicular distance between the center and the chord is equal. So that is OM is equals to ON. Equal chords are equidistant from the center. That is the theorem number 3. Okay, theorem number 3 is equal chords are equidistant from the center. Now we move on to the next theorem, and that is the converse of this thing. यानी क्या अभी क्या होगा? पहले में क्या दिया था? Chords are equal. You need to find that they are equidistant. Now you are given the equidistant. You have to prove that the chords are equal. So automatically again the same change. This becomes the TPT and this becomes the given. Okay. So you already know that OM and ON are equal. So we do not know that these are equal. So this is not known. But you know that this is equals to this. You need to prove that AB is equals to CD. Okay. So we are going to again do the same thing. We are going to prove the two triangles congruent. So you can see here that if I am taking these two triangles, I know that this side and this side are equal. This is 90 degree because that is by construction itself. Okay. O and OB are the OC are the radius. So automatically I have the two triangles to be congruent. So AM will be equal to CN. If AM is equal to CN, we can say that AB will equal to CD because perpendicular drawn from the center to chord bisects the chord. So in this way, you will be having that the two chords are congruent or equal. So we have over here in triangle AMO and triangle CNO. AO is equals to OC radii. The next is angle AMO is equals to angle CNO, which is because it is perpendicular given. The next is we have OM is equals to ON, which is given. Accordingly, we have triangle AMO congruent to triangle CNO by the test. What will be there will be RHS test. Once you know it is the RHS test, then you know that AM is equals to CN. Okay. Therefore, AB is equals to CD because perpendicular from center to chord bisects chord. Okay. So this is how you are going to just say that AM is equal to CN. So it will be, but if you want, you can elaborate it at what they are given in the textbook. So that is AB is equals to twice AM and CD is equals to twice AN. Sorry, CN. Because of this reason. And then you can just say that AB is equal to CD. Right, so this was the theorem number 4, that equal chords, are equidistant from center ka ulta, that is converse of that thing. So converse of that will be if two chords are equidistant from the center, then they are equal. So chords of the circle that are equidistant from the center of the circle are equal. So that was theorem number 4. We now move on to theorem number 5. Now theorem number 5 states that one and only one circle can be drawn from 3 non-collinear points. Okay, there could be only one and only one circle which can be drawn through 3 non-collinear points. So here you do not have the proof of this thing in a proper manner because it is basically construction based. So you need not learn this particular part. So the theorem ka proof learn करने की जरूरत नहीं है. You can just understand it properly that if I got 3 points, 1 point, 2 point and 3 point, and if these are, of course you can see that they are non-collinear. What is collinear? Collinear is like this, when they all the 3 points are lie on the same line, they are collinear. So this is collinear. Whereas if they are points like this 1, 2 and 3, I cannot join it by one single line. They are different. So when I am having this something like this, then they are called as non-collinear. So if it is a non-collinear line points, if the 3 points are non-collinear, then if I want to draw a circle passing through all 3 of them, I can draw only one circle which could pass all three of them. That is how we are doing it is, I am going to join this two, draw the angle by a perpendicular bisector of this thing. I am going to join this two and draw a perpendicular bisector of this thing. Now the point of intersection of this thing is the center of the circle. Take this much as the radius, or this much as the radius, or this much as the radius, and draw the circle. So you will find that the circle can be drawn like this, with the center as this particular point as the intersection of the two perpendicular bisectors. So this is just the theorem that one and only one circle can be drawn from passing through three non-collinear points. The corollary to this is that in a plane of circle, the perpendicular bisector chords of the circle passes through its center. So if I draw any perpendicular to any chord, then it will be passing to the center. And the perpendicular bisectors are two non-parallel chords of a circle intersect at the center. So yeah, if there are two non-parallel chords and they are going to be perpendicular bisectors which are made through them, they will be passing through the center, intersecting at the center. And finally, as there is one and only one circle passing through the non-parallel point, two different circles can meet almost at two different points. So if I got two different circles, they can meet at two different points. Maximum number of points which they can be intersecting be just 2 points. That is what is at intersecting circles. So anyway, the corollary part is not so important. Many you are not using it in any of the questions. Most of the things we are using that theorem only. So that was about the phi theorem. So we just recap the phi theorem. The first theorem was that the straight line joining the center of the circle to the midpoint of the chord, that is the straight line joining the center of the circle to the bisector of the chord is going to be perpendicular to it. So that is the first thing. The converse of that thing will be perpendicular drawn from center to the chord bisects the chord. That is second, or the converse of the theorem. The third theorem will be equal chords are equidistant from the center. So that is, if two chords are there, then they are always equidistant from the center. The distance between the perpendicular distance between the center to the particular chord will be equal. The fourth one will be converse of thing, that is, if the two chords are equidistant from the center, then they are equal. So that is the fourth one. And the fifth one is that one and only one circle can be drawn passing through three non-collinear points. So these were the theorems which are going to be there for your chapter of circles, the phi theorems. So based on the phi theorem is our first exercise over here. This first exercise is exercise number 15.1. So we start with the exercise 15.1. We'll be doing the alternate sums. So let's start with sum number 1. Okay, let's start. That is exercise 15.1. The first sum. Calculate the length of a chord which is at a distance of 12 centimeters from the center of the circle of radius 13 centimeters. You need to find out the length of the chord which is at a distance of 12 centimeters from the center. That means they are given you the circle. See, always it is important for you to draw the figure for any question in circle, so that mentally you are sure that what you need to find out, and it is also compulsory to draw the figure. So draw each and every figure whenever you are whenever you are solving any circles question. Okay, so you are given over here that this is the center of the circle and this is the chord, and they are given that this is the perpendicular distance over here is 12 centimeters and the radius which is here is given to you as 13 centimeters. Okay, this is given to, so this is a question. Calculate the length of the chord which is a distance of 12 centimeters from its center. So this distance is 12 centimeters. We can just mark it as O, A, B and M. So given over here is OM is perpendicular to AB and OM is equals to 12 centimeters and radius is equals to OA is equals to 13 centimeters. Accordingly, we need to find out AB. Find AB. So firstly, we know that First we will write over here that in right triangle AOM, AM square is equals to AO square minus OM square, that is by Pythagoras theorem. So that's going to give me 13 square minus 12 square is equals to 169 minus 144, it's 25. Therefore AM is equals to 5 centimeters. Okay. Now we know that perpendicular from center chord bisects the chord. So we know that AM is equals to BM because perpendicular from center to chord bisects chord. Accordingly, you get AB is equals to 2AM is equals to 2 into 5 is equals to 10 centimeters. So AB will be 10 centimeters over here. Clear? That was sum number 1. Easy sum, very easy. But you can see it is easy only after you draw the figure. Only after you draw the figure, you come to know that it is forming a right angle triangle. So you can use Pythagoras theorem and get the answer. Okay, so as I told you, drawing the figures very, very important. We now move on to sum number 3. Third sum. A chord of length 8 cm is at a distance of 3 cm from the center. Calculate the radius. Simple again. This is the circle. This is the chord. The distance between the center. The chord is of 8 cm. So A, B, M is 4, 4 each because its total is 8 and it is 3 over here. So this is what you need to find out. So it's given over here that AB is equals to 8 centimeter. Therefore AM is equals to MB is equals to 4 centimeters because perpendicular from center to chord bisects. Okay. So therefore it is 4. So OM is equals to 3 given to you. It's given. Therefore OA square is equals to AM square plus OM square by Pythagoras theorem. So it's 4 square plus 3 square is 16 plus 9, 25. So OA is equals to 5 centimeters. That's the radius. So radius is 5 centimeters. Easy sum. We now move on to sum number 5. Sum number 5. A chord of length 16 cm is at a distance 6 cm from the center of the circle. Find the length of the chord of the same circle, which is a distance of 8 cm from the center. Okay. So you got now 2 chords. One chord is of length 16 cm at a distance of 6 cm. So you got over here 2 chords. So this is the first circle. One chord is over here, another chord let it be here. You can draw it any way you want. It's just pictorially you are drawing it. So if this is the condition like this, then you know that this will be the radius over here. They given you that a chord is 16 centimeters. So if AB is 16, so you know that it will be 8 each. Okay, and the distance from the center is 6 centimeters. Find the length of the chord of the same circle with a distance of 8 centimeters. So this is 8 centimeters, this is N, this is C, and this is D. What do you need to find out from the center? So this is the question you need to find out. So it is given that AM is AB is equals to 16 centimeters. Therefore, AM is equals to BM is equals to 8 centimeters. That is perpendicular from center. I just cut it short right now. I am not going to write it each and every time the long thing. So, but in the examination or any point whenever you are writing, of course in the examination you will write the complete theorem. Perpendicular drawn from center to the chord bisects the chord. You need to write that thing, otherwise you will not get fetch marks away. So right now, because we are going to write it in each and every sum, that's why I am not writing it over here. So this is 8 centimeters. Now we know that OM is 6 centimeters given. Therefore, OA square is equals to OM square plus AM square, that is by Pythagoras theorem. So this gives us as 6 square plus 8 square is 36 plus 64 is equals to 100. So OA is equals to radius is equals to 10 centimeters. So that means OA is equals to OC is equals to 10 centimeters radii. So now this is 10 and this is 10. You need to find Cn. So Cn square is equals to OC square minus ON square by Pythagoras theorem. So that is going to be 10 square minus 8 square is equals to 100 minus 64 is equals to 36 is equals to 6 centimeters. So we have over here that Cn is going to 6 centimeters, right? Therefore, CD is equals to 2 into Cn because perpendicular from center bisects. So 2 into 6 is equals to 12 centimeters. So that gives you that CD is 12 centimeters over here. That is question number 5. We found out the length of the second chord, which was at a distance 8 centimeters from the center. We now move on to sum number 7. There are two sums in sum number 7. We will do both of them so that we are, because I can see all others are only single. Only the last 3 they are different. So I will continue with the 7th and then 9th and 11th. So I will do both the sums of 7th. Okay, sum number 7A. So you have over here a circle with the 2 chords, one chord like this, one chord like this, center O. You are having this one OM, AB and ONCD. You are given certain data over here that this is perpendicular, so OM and ON are perpendicular, so that makes it simple. And AB is 24, so AB is 24, this will be 12 each. And you are having ON and OM is 5 and ON is given as 12. Okay, 5 and 12. You need to find out the radius and the chord. So exactly identical to the earlier sum, that was the 5th sum. So we will be finding out the radius like this. So this is the radius and this is the radius. So first of all, AB is equal to 24 centimeters given. Therefore, AM is equal to BM is equal to 12 centimeters because perpendicular from center bisects chord. Okay, so that is 12. Now we know that OA square is equal to AM square plus OM square because of Pythagoras theorem. So accordingly it will be 12 square plus 5 square is 144 plus 25 is 169, so that is 13. So OA is equal to 13 centimeters. So radii OA is equal to OC is equal to 13 centimeters. That was the first part, that this is 13. we need to find out is the length CD. So for length CD, again the same thing. We have got over here Cn square is equals to OC square minus ON square by Pythagoras theorem. So that's going to be 13 square minus 12 square is 169 minus 144 is equals to 25. So Cn is 5 centimeters. Therefore CD is equals to 2 into Cn because perpendicular from center. Okay, so that will be 2 into 5 is 10 centimeter. So that was the 7th ka first part, first sum. Now we move on to 7th ka second sum. Okay, very easy. Basic एक ही theorem continuously we are using and the Pythagoras theorem. So quite easy, very easy in fact. Okay, now we move on to sum number 7b. Okay, we have got over here the sum which is like this, that this is the diameter, this is the chord over here is 4 and 4 and this is 3, this is the center O. This is B, E and A. What is given to you is B is equal to A is 4 and C is equal to 3. You need to find out the radius. Okay, now over here we can see that if I join this is C, I know that OB is equals to OC is equals to R. Therefore, OE is equals to R minus 3 because it is nothing but OC minus OE is equals to R minus 3. So this over here is R minus 3 and this is R. Now I can use Pythagoras theorem over here. So I know that OB square is equals to OE square plus BE square. That is by PT, Pythagoras theorem. So this gives me R square is equals to R minus 3 the whole square plus 4 the whole square. Got it? This is R square, this is R minus 3 and this is 4. So that is what we need to have over here. So this gives you R square is equals to R square. Now this is A minus B the whole square. A square minus 2AB plus B square. A square is R square minus 2AB, that is minus 2 into R into 3 plus 3 square plus 4 square is 16. So this R square and R square gets cancelled. So it is equal to 0 is equals to minus 6R plus 9 plus 16. Okay. So this gives you 6R is equals to 25. So R will be equal to 25 upon 6. So that is going to give me as 1 upon 6 centimeters. So the radius of answer 7b will be this way. We can just check up the answer because it was slightly awkward answer. So we'll just confirm that thing. Yeah, whether it is the same thing. So this was exercise 15.1. 15.1. We are the 1 upon 6 centimeters. Got it? So this was sum number 7b. So this was 7b over here. We now move on to sum number 9, but I think I'll take it in the next video. So that will be sum number 9 from next video.